Okay, first hour, May 24th. Today we're going to talk about data cleansing, data cleaning, data processing, dirty data, um, and what that means to you guys. I'd like to know individually what steps you go through um, to cleanse data, to convert, get it ready for analysis. So I have a PowerPoint that I developed. And I know you're all thinking, yay, Don's got a PowerPoint. Good morning, Chris.
Hey, good morning, everybody.
Okay. So yeah, let me share this presentation. And this is just using just a few slides here. Conversation starter from uh, the Google Career Certificate Data Analytics course. Some good graphics, good thoughts, and good uh, extra resources if you're so inclined um, to look at what other people are dealing with in the world of dirty data. It can get a little monotonous. I remember cleansing data coming from several different military readiness systems, and you get used to a checklist of what you're doing, and that's good. Everybody knows what you're doing to convert the data. One of our things to talk about here, but yeah, I'm going to talk about cleansing data and the issue of dirty data, um, and what it means to you as an analyst, and what all you do to deal with that. And then when this presentation is done, we're going to jump back into Python to the next session of Python. So yeah, what is dirty data? You know it when you see it. Uh, uh, you can have duplicate rows sometimes, particularly uh, cutting and pasting, but even a SQL query can do a join weirdly and wrongly and throw in duplicate rows. So you never know. Um, uh, Data that's outdated, that's I wouldn't consider that necessarily part of dirty, but Google does. But it could be something you need to clean out of your data set because it's prior to the window that you've been asked to analyze. So absolutely, you could sort things by date and get rid of that. And I'm intentionally avoiding talking about these in terms of Excel, which is what a lot of us wind up using to do conversions and sort and filter and whatnot, because we do the same thing. We can do some of this in SQL. We can do some of it in Excel. We can do it in Python, um, or something like SSIS, ETL tools. You can wrangle and transform data. So I'm intentionally avoiding a specific implementation and just talking more in general about it. Incomplete data could be a column that you need that you don't have, an attribute, or could be rows that you don't need. Maybe you don't have the numbers from one of your stores or one of your clients or something like that, one of your uh, main accounts. Incorrect, inaccurate data. That's, I think, what a lot of folks look for. And go through and do some level of sanity checking to make sure that what you're running through your model, whatever that may be, or throwing into your graphs is correct and accurate, because somebody's going to ask, where'd you get those numbers? Anybody question anything that you guys have put out yet, as far as like, that's not what I was expecting? Where'd you get that? Where'd you get that data? Or where how do you figure? Anybody ever question anything? Ever?
Yes,
Yeah, every so often a client of ours will put in data that's like a whole lot larger than it should be compared to the previous years. So we'll send them an email or something to confirm if that's the right number. Most of the time it's not.
So an outlier alerted you to something suspicious,
Yes.
and it was just a data entry error.
Sometimes it's just like, like sometimes they put in the wrong number like manually, or sometimes they just get the wrong number and then they put that in, if that makes sense.
Fair enough. Sure. User data. I've done it myself, I'm sure, many times. Chris, you looked like you were going to jump in.
I was just saying, yeah, I've encountered that before. Maybe it was something off of the query that caused me to get maybe some bad data, date ranges, maybe added a branch I shouldn't add it, something of that nature.
Sure. So that's, introducing a processing problem into the data, and that can happen. So and then inconsistent, that could be inconsistent formats. It could be you could pull in one data set and it's in Fahrenheit, and then you pull in something from somewhere else and it's in Celsius, or whatever the case may be. So the data doesn't line up. And then this next slide, these slides are in the classroom under foundations. It's the last file in the foundations module, dirty data. It's called dirtydata.ppt. And these are actually links. One of them's MIT Sloan Management Review. It's pretty reputable source. So this is the impact of dirty data, and this is industry wide. You know what I mean? The actual impact of dirty data to you could be, something being delivered to an old address, and wow, I mean, an important purchase that you really thought was going to get here on time went to the wrong place because the company had an old address for you, or something to that effect. Most of us, I believe, are used to absolutely perfect data when it comes to our bank accounts. That is one thing. The banking industry does not fool around with the trustworthiness of transactional data with your bank account. Whenever anything's off, you can get to the bottom of that. But a lot of the stuff we're talking about is softer. It's less. I mean, banking software is audited. It's I'm maybe even more trusted than medical software, because of the scrutiny that's applied to it. So anyway, I think there are perhaps inaccuracies in the data that they hold about you, maybe like bad addresses, bad phone numbers, those sorts of things. But anyway, here you go. This is straight from the Google. I know, like, for sure, advertising, man, they blow a lot of money on just, I don't know what data they're using, if any. So that could be a problem in and of itself. I don't know about necessarily dirty data, but it might be bad, old, outdated. Some of the other factors that we discussed in the previous slide, and even healthcare. Missing blank stuff is stuck at one practice versus another. We still don't have a truly universal EHR system where absolutely every time you've seen a doc, every prescription has been written, every diagnostic image that's been taken of you, every test, every EKG, and think of, through a lifetime, all of that medical information that could be made available to your healthcare practitioner. We're still not there. So anyway, just some food for thought. And these are some pretty good things to think about as you're cleaning your data. Could be maybe worthy of a checklist. And one of them Yeah, the second one, the second X there, especially. So yeah, spelling errors. Sometimes things can be, fat fingered in, and it meets data validation, but you you spell something the wrong way once, now you have a completely different instance of that. So you throw it in a pivot table or whatever, and now it looks like you've got a north branch and a Nurth branch or whatever the case may be. So spelling problems. One of the things that jumped out the most at me as kind of I'm a software engineer, process repeatability kind of guy at heart. And when forgetting to document the errors, I wanted to share there's a slightly more detailed explanation here. On what each one of these are. And again, this is just right out of Google's training material. Forgetting to document the errors can lead to them coming in over and over again. To me, I think of putting in a software ticket. Especially the larger the organization, the more people involved with fielding the application, developing the application that users are using, data engineers that are moving that data around. You as an analyst that's maybe pulling some stuff and have your hands on it. When you're seeing problems with the data, it can often be back to either a software or a process problem. And if it is software, it could be you need to put in a ticket so your application developers do a slightly better job of capturing something or converting it or error checking it, forcing the user to enter something before they move to the next screen, those sorts of things. So it could be that you got to work with an application developer. It could be that you got to work with a data engineer. Like Seth, my son writes SQL queries that I think put data in the database you use. So Arkansas is a small town, it's small world. And it could be that the requirements that were generated for that query were inaccurate, or the developer left something out, and you need to put a ticket in to get that query to operate differently. It could be stuff that you're doing that you can't really ask anyone else in the process to do. It's just unavoidable. And that's where it's good to have some sort of documentation for your products, for your analytical products. It could be as simple as a markdown cell in a Jupyter notebook, and you use that Jupyter notebook as a configuration item. It could be comments in a Python script that document what it is that you're doing. But yeah, documenting the errors, definitely a big part of making sure you are in a constant improvement cycle. Misfielded values. Yeah, that's particularly if people are entering data in a spreadsheet manually. There's not a whole lot of error checking, but there was a time, and still applications where people are entering stuff into a spreadsheet. And this one, it's like you're in the wrong column, so you just entered an invalid value in that column. And since it's not like an application where you can do error checking, it's easy to get those sort of things in the wrong field. Missing values, nulls will cause divide by zero problems. Like a null row in a spreadsheet, you guys know, will mess up a lot of your like auto summarizing and tables and whatnot. So missing values, definitely something to take into account. And looking at a subset of the data, not the whole picture. That's just kind of focusing on a portion of the data, yeah, and not looking at all of it. Losing track of the business objectives. This is funny. They could have just said getting distracted, but sometimes when you're working in data, I know I am because I'm just a really curious nerd. You start looking at stuff that sends you down a rabbit hole. And so all that is doing is just encouraging you to stick to the analysis at hand and putting curiosities that bubble up as you are working with the data in another on a list of things to check out, when the boss isn't waiting for this report kind of thing. Not fixing the source of the error, that goes back to what I was talking about, documenting the error, figuring out why you're constantly seeing data in the wrong format or whatever. Could be an easy fix if it's part of an automatic process. Again, could be an easy fix if it's something within the application, either allowing a null or not bounds checking. Not like calendars are easy now. You put a little calendar widget on the website, and now you have to pick a valid date. So there's no chance of you entering something incorrect in that regard. Not analyzing the system prior to data cleaning, so you know what you're dealing with. Bottom row, backing up your data. Yeah, I'm a particularly a digital hoarder. I think I if I get a spreadsheet, a worksheet, and I want to start like eliminating columns, that's a lot of things you've got more data than you need, so getting rid of irrelevant data. But I always keep that initial sheet. It's just I try not to ever mess with the source data, because so it's always there when you can roll back. And the other one is in your estimating process. When somebody asks you if you can have that report done by the end of the day, kind of think about the trustworthiness of the data and how long it's going to take you to clean things up, to include those software changes I was talking about. You may need to actually wait until the next agile scrum to get your requirement fixed, which will affect how long it takes you to get questions answered as an analyst. So cleansing data, the how much time. I'll start at the top of the screen. Kevin, what are your experiences dealing with dirty data? What sort of conversions and extraneous nonsense do you have to deal with?
Most of the time, it's just user error whenever they're inputting data. We just have to double check with the client to make sure that it's the right number or if it's in the right unit. Sometimes whenever, like recently, we made like a program to parse through some of our values to check for any errors. And we got a bunch, but apparently it was actually the program that wasn't made correctly. So some of the errors weren't actually errors, if that makes sense. So I guess that was bad data about bad data.
Well, they were errors, but they weren't user errors. It was application error.
So it wasn't any errors about the data that it was checking. It was errors with itself, if that makes sense.
Okay. So when you're in, what do you clean things up with? What's your tool of choice?
Usually we just double check with the client to make sure the numbers are correct. And if it is, then we'll leave it at that. If it isn't, then we just gotta wait on the client to give us the correct data, because usually they're the ones who are tracking like their usages, or their like how much water they use, or how much production they had. We're just making sure that it's input correctly. But sometimes we have, like, we call them indicators, and they have they calculate other values like emissions or something based on what the client puts in. And every so often, intellects won't calculate it correctly. And that's what our error checker is to calculate it on our end and compare it to intellect's value. And if they're not the same, then just query intellects to recalculate it.
Interesting. Okay. How about you, Seth?
Most of the time it's just trying to make sure everything looks right. I've had a time or two where I'm trying to access data from our warehouse, and I've had times where the columns are like, the values are reversed in a couple columns. Like a column should be site ID and then site name, but they're reversed so that site name has all the site IDs in it. And so I have to push that up the line to our database guys, probably the guys upstairs, and they have to go in there and fix that for me.
That's easy enough to do. You get a column out of sequence in a select statement, sure enough, and save it that way. Interesting. So how do you make sure everything lines? You say the way you said it, everything lines up. What are some steps you take?
Mostly, I don't know, like we're looking at pretty small sets of data most of the time. Most of the time I'm just looking at it, right? Try to see if anything makes sense, like if there's a bunch of nulls where there shouldn't be, or things like that. That's what I look for.
Okay. Yeah, nulls drive me nuts. When we get done with this, I'm gonna pull up a Python notebook I wrote to help me. And I'm curious if you guys would go about it a different way. You guys are probably in Excel much more than I am. Edgar, what's data cleansing mean to you in your world? Bummer. Yeah, still can't hear you, buddy. If you think you get it fixed up, come off mute and just holler, and it's just us. There's just 5 of us now. And Chris, I haven't picked on you yet, have I?
Oh, all right. For me, the majority of my cleansing falls into the incomplete data category. There's a ton of fields that's missing. Like for instance, I may have some post office boxes instead of physical address, and I have to go dig around in the core system and look through long documents to find the correct physical address. And other categories where maybe the front end staff, they didn't maybe gather some of the data I needed, like so especially like some of the impact data, like I may need it, like some race codes or other demographic data that we use for some of the impact reporting. And that's always a challenge. Like I said, when they don't have it and I need it, I have to kind of manually look for some of the stuff. And then in some instances, there's some inconsistent data where on one product or one loan, a business may fall into an individual category or consumer type product when it should be a commercial, and you have to kind of sort and watch for some of those so you're correctly listing your consumers in one batch and then your commercial customers in another, because it may be important for a particular report. They may only want to see small businesses and not consumer, or vice versa.
Is that manual? Do you have to like go through and make sure it looks like the name of a person instead of the name of a business?
Well, sometimes, so I key off different things. Like for instance, no individual should have a NAICS code. That's a key indicator that should be a business. So if I look through my data and I see NAICS codes attached to individual accounts, yeah, somebody definitely kind of categorized something wrong. So just finding whatever the field is to try to save some time. And for your second question, my software choice that we're primarily rely on 99% of the time is going to be Excel.
Sure enough, yeah. Yeah, so there's a you ever use that COUNTIF function?
I have not. I do use VLOOKUP a ton.
Yeah, I think we'll learn that next week's our Excel crash course. And like I said, if you guys are churning and burning all day in Excel, you may not learn anything new. But I like Mary Kate's her name. She's a spreadsheet whiz. at South Arkansas University. Anyway, she does a really good job and of going through like Excel functionality. So yeah, there's a function there that would count if a value was null, say, or a value was in a range. You could use it if you had just um, thousands of rows. That's when these things come in. If you can see everything in a page or two, then a lot of this automation doesn't really pay off. But yeah, there's functions out there that would alert you to whether or not something, the number of non-nulls. Then you can always do sort and filter, and it'll start to tell you what you've got up there. And we'll go through all that kind of stuff next week. Python, you can change all of your nulls to 999 or some other number, that there's some other thing that's guaranteed. I don't like the actual null being there. I like testing for a character. I don't know, just an idiosyncrasy. So anyway, yeah, there we go. And Dexter, how about you? Are you dealing with dirty data at all, or is your monitoring function more like you got to trust what you see? Okay, I know Dexter's with us, but
Yeah. Well, I mean, we at the same place, so but yeah, we just use what we got. What do you mean? Like, I didn't catch the first part of the thing. But what is dirty data?
well, it's I've got the
Like
screen.
briefly.
I'm screen sharing. Yeah, so it's data that you can't trust, stuff that's in either the wrong format, or it's missing,
Like
or
sometimes we have errors where it come in the wrong format, but for the most part, we just trust what we see.
and when it's in the wrong format, what steps do you take?
Uh, like we have to we have to contact certain people to, you know what I'm saying, for them to let us know what they doing, because sometimes they change the format, if that
Okay.
makes sense. Sometimes they'll change the format, so we'll have to change our format to match theirs.
Yeah, there you go.
Change our tables to match theirs. Yeah.
There you go. Yeah, so that letting somebody know that's to me, that's the second one from the top left there. Forgetting to document errors these are pitfalls. These are things you want to not do. So it sounds like whenever you get an issue like that, yeah, you're alerting the right folks and making sure that gets documented in the
Right.
process. And yeah, that can, man. People change. Sometimes people will change the format of something, and all of a sudden something breaks, and you got to figure out what happened. I was exchanging data with an advertising agency back in the day, and the my export had to match their import perfectly. And if we did a software change and didn't think about the interfaces, that's in a software testing world. That's one of the things your software folks should have in their checklist, is testing the interface, and that will also include your your data warehouse, your data pools, for analytical purposes. So hopefully people aren't changing things without thinking about who all what all effects that software change has. All right. Okay. Yep. Just wanted to cover that real briefly. And when we come back, it's gonna be pure Python. So let's take till 10:15, 10:15, and we'll reconvene.
All right.
Okay, welcome back, guys. Second hour, May 24th. First thing I wanted to do was go over Python exercises 1. Everybody got that handed in. Hey, Seth, are you back from break?
Yeah, I'm back.
Hey, man, can I pick on you? You turned in it's good picking. You turned in a very complete assignment.
Sure.
Can I show your notebook? All right. And if the answer is no for any of that ever, if I'm, ever embarrassing you, you can say no. Let's see. So Python exercises 1. Thank you very much. Everybody put their name on here. Appreciate it. Let me see if I already opened it. Yep, I already opened it. Okay. So I just wanted to go over the solutions real quick. Seth knocked them all out, including the extra credits. Why you were the only one that attempted that one. And it looked great. Okay, so yeah, first one's just hello world. Second one's easy length times width, and this format mask. Like I said, if you're working in Python and you're going to wind up doing like a script that runs overnight, and people are looking at the numbers, you're going to want to learn how to format. For my purposes of just hacking stuff out, I'm lazy. I never really got very good at it. But that .2f is 2 decimal places floating point, so it's kind of like almost like a formatting code. Those masks there. Number 3 was same thing. You had a magic number here, which is the 43,560. It's the number of square feet in an acre. And one of y'all did several of them. Several different conversions. Generally speaking, you guys are the strongest in Python that I've seen in the 4 cohorts we've had. So this should be pretty interesting. We should be able to get pretty far. And then the bottle deposits, you're getting 10 cents back on a small, so less than 1 liter bottle. And for a liter and above, you're getting a quarter. And I actually remember the bottle deposits, and and the big Coke bottle was a quart, which when I was a little kid seemed huge, but they're really just not that. They're not that big. But yeah, it was a thing. I don't know. It really isn't a thing anymore. When I was a little kid, they added on to my neighborhood, and the construction workers, so they're building houses, and the construction workers weren't worried about these glass bottles and their deposit, and they would take one out of their cooler, slam it, throw it down wherever they were, whatever, and leave. And one weekend, a buddy of mine and we must have been, I don't know, 8 or 9, took a wagon back there, and we had as many glass Coke bottles, which were all deposit, as you could stack on like a red whatever, a little red wagon. And we we walked those things all the way to the 7-Eleven. And even as an adult, I know it's like a mile. And we were young. I mean, we couldn't have been more than 10. And we took that whole wagon full of bottles to the store and got the deposits back. And man, we were rich. I don't know if we got $3 or whatever it was, but yeah, bottle deposits. So there you go. We're getting 10 cents back on liter or less, $0.25 on for more than a liter. And we multiply our small bottles by that deposit rate plus our large bottles by the large deposit rate, and we get our total refund. Even or odd, only saw an issue or 2 here. And this is a mathematical test that you don't use every day unless you're the exception. And here we do test number mod 2, and any number mod 2 being equal to 0 means that there's no remainder. So 4 divided by 2 divides evenly. There's no remainder. 4 is even. 6 divided by 2 is 3, no remainder, 0 remainder. So that's the mod operator. And it comes in handy whenever you need to check if something is evenly divisible by something else. Just so it could be if you needed things that are evenly divisible by 3 or whatever, you can, it's the same concept, but it's called modulus, modulo. Most folks just say number, mod, whatever, mod. So yeah, Seth knocked that out. Good job. And then here's the so Seth, what did you do to get this flow chart into your notebook? What were the steps you had to take?
Well, getting the image was a little tough because I tried to just copy the code that you had in there,
Mhm.
but for some reason the reference didn't work. Whatever you were referencing, my computer couldn't find it, right?
Right.
So I just saved the image as like a PDF, not a PDF, it was an image or something. I can't remember exactly. And then I
JPEG or
just
PNG or
yeah. Then I just inserted it in there in the code. And then the one below that just had the question, or that was easy enough to put in.
Sure. Yeah, I was wondering if you figured out how to like copy a cell into another notebook or something like that. I was surprised to see the image in there, but yeah, that's probably what I would do first is, yeah, just download the image and then you do is it edit insert or file insert? Edit insert image, yeah, when you're in a markdown cell. So, and they come in handy. I mean, depending on what you're doing and how much documentation you need of what's going on in a notebook. Anyway, yep. So here's the program. Now, when I look at this, my initial going in thought was that I'm going to have 2 if else blocks. But I think your solution was more elegant, Seth, because really, if you look here, what you've got is 3 income levels, right? Less than 24,000, greater than 24,000, but less than 52,000, and then greater than 52,000. So you really have 3 cases, and the way you put them in here is in the appropriate order, and it checks and does the true leg for if the income is lower than 24,000. Else it does this check, the diamond over here on the right, if that taxable income is less than 52, and does the left hand side of that. Otherwise, it does the right hand side no matter what, and formats it appropriately. So well done on that. So if anybody wants to knock it out and has any trouble, I'll leave it on the screen here. You can always play the video and pause it if you want to try and knock that out. But yeah, it made elegant sense. My going in thought would be to do a, if taxable income is less than 2,400, then an else if income is less than 5,200, and that's not the elegant way to do it. If you sit and really analyze the programs, So well done, Seth. Thank you.
Thank you.
Okay, so that was the homework. Again, any trouble, or if you had something you wanted to discuss, there was one other. Oh yeah, from last time. Let's see, file, close, and halt. I believe it was Edgar, but it might have been Kevin. Somebody asked about like validating user input, kind of like and looping through it to check user input. Can anybody, Edgar, even if your sound isn't working, was it you? Can you do a reaction? Like hold your hand up or It was Edgar. Yeah. So, of course, I forgot until just a little while ago that Edgar had asked that question. So, I did a little Python Googling, and it gets a little complex, but it made me want to do a notebook and stop avoiding it because it's a good point. The the thing is that I think most of the programming that you guys do will not be like an interactive program. Yeah, I don't think you're going to be sharing these notebooks with somebody and then doing data validation and telling them, well, enter this and enter that, and then validating that input to make sure that it's the right data type or it's within the right range. But you might be able to, and it's a good thing to know about, and it introduces a couple of other topics in Python that I don't normally cover, but I really feel like I need to. And those are a decision structure called try, and the concept of exception handling. When you do either a logic, normally a logic error in Python, not a runtime error, not a syntax error. If you have a logic problem in Python, you can, it's called trapping. You can trap that error and do something about it besides just bombing. And I've got a few examples of that. And then, Edgar, there's a couple of different ways to check user input. So we start with the and yeah, don't necessarily worry about what I got here. This is something I'm working on the screen. We start with the input function, and that is a string. So it automatically returns a string no matter what's in it. But then there's let me see if I can find the right notebook. That's something I wanted to show you, but that's not the one, not a Zoom. This is what I'm working towards, is actually doing this try and exception handling all in the same loop. But let me try and find, I know I had it here. Hang on. Okay, here's the basic. Can you guys see this okay? This block of code right that I'm highlighting right now?
Yeah.
You read that all
Yeah.
right? Okay. So what this block of code is doing is getting an input from the user. They're going to convert, the Richter scale, what goes up to what, 9 or something, or goes up to 10, but it's logarithmic or exponential or whatever, like a 9.2 tornado. A 9.2 earthquake is like 10 times as bad as a 9.1 or whatever. So anyway, this is just an example of gathering input. It comes in with the input function, so it's a string, and then you can do what's called a try except block, which is almost like a decision. It's almost like an if then else. So what it does is it tries the commands underneath that try block. You see there's the try and a colon and then the white space. It looks a lot like an if then else block of code, or a looping block of code. And it's important to keep these small, because if you put a bunch of stuff under the try, it'll try it all, and you don't necessarily know which one is giving you the error. So very often, if you're doing anything that can cause an error, you'll do a small try block. But anyway, this is the syntax for it. So what they're doing is they're trying to convert x, terrible variable name. They're trying to convert x to a float. And if it is not in the format of, you know, number, dot, number, if it's not in floating point format, as we've seen, it will error. So what the except does is trap that exception, that error, and you can name the type of errors. And this is where it goes down the rabbit hole. There's a bunch of different exceptions that you can trap and deal with. The conversion error that we're trapping is a value error that the float function returns because you sent it something that it can't deal with. So that's what value error is it's the return value from that float conversion. So if we do it in an except block like this and then print, sorry, that's not a valid float, it will avoid throwing that error. And now where I'm at, so any questions on this? Is how Python does error trapping and exception handling. It's just a kind of an advanced topic. Any questions on that block of code?
No.
Okay, so what I got into the middle of with, 20 minutes to go, I'm sorry, I had an appointment this morning I couldn't avoid, which is what made us get a late start. I got into a notebook that would put this in a while loop so that it would loop through and try to do the conversion until it was successful. And it kind of got me into further than I wanted to mess with today. So I'm going to keep working on that, and I'm going to go back to our normal, our regularly scheduled program today, talking about just basic looping with Python. But this is that it's called Stack Overflow, and it is the most, I would say, most complete and complex social media site that you can ask a programming question. Here's a guy with trouble with a data validation routine, and then you get answers from people on Stack Overflow, and it's like anything else. It's like any other free advice social media site, but you can kind of tell, and then there's people can rate the satisfaction of the answer. But yeah, you'll see if you Google how to do something, you'll see that on Stack Overflow. If you're not familiar, I apologize if you guys are all over it. So that's Stack Overflow. There was one, so let me get rid of that. I'm going to start closing out links as I covered that one. It seemed like there was another one. Yeah, it's a try within a loop. And then they use a break command, which I don't cover because I don't like it. And we'll talk about that in looping, the other example. But there's also, there's also like an is numeric string. This is another one, another approach. This doesn't loop, but it defines its own function, which we'll get into in Python. You can define your own procedures. This tutorial defined is float that uses a try except block to do the checking to see if it is a float or not. And you can do then you can do if logic, if is float, then you do the conversion. You're not actually converting really. You're just checking it up here in the function. That's another approach. Like I said, I need to do a whole notebook on this, so that because I can't find what I'm looking for, which would be a Jupyter notebook with clean-cut examples of validating different types of data. But I want to say, I must have used that tab. because there's a string method called is numeric. And I don't want to get into that because I got a notebook on strings. There's a lot of stuff you can do with strings when you're dealing with a string literal or a string object. I don't want to get into, but one of them is a method that checks to see if it's numeric, but it doesn't work on floating point. It doesn't seem to be a built-in one size fits all, string method for data for validating that input data. So anyway, see this, I love getting questions because it sends me down the rabbit hole, and that's the way I learn, is just bashing my head against a problem until I feel like I've got a decent handle on it. So I'll keep working on that data validation, input data validation, because you might write a procedure that that somebody runs, and it may not be you. It may be a clerk or somebody, and you might want to do some data validation. Not necessarily in a Jupyter notebook. It could just be in a script that runs from PowerShell or whatever. All right, let's get on with notebook number 4. So this one is in your classroom under Python programming. And we talk about the basically the 2 types of loops, or repetition structure in generic computer science language. So I cleared all the outputs, cell all output clear, in case I didn't do that for you guys. So yeah, we've got many times that you want to cycle through a set of a block of code more than one time. Like those, you guys that have written, SQL queries, that's kind of built in. That loops through your data and applies your where clause to each row of the data, but you don't have to tell it to loop. It's part and parcel of the language. But Python, you control every aspect, everything that's happening. So very often you want to use a repetition structure, and Python has, just like every other language, there's two primary basic types of structures. Dexter, did you have a question?
No, sir. I was just trying to see if my mic worked.
It does.
Okay. Thank you.
Sure. So yeah, there's generally 2 kinds of loops. Some would say 3, but we're gonna deal with put them into 2 categories. And the first one is condition controlled, where it will repeat as long as your test condition is true. And the other one is sometimes you want to do something exactly a certain number of times. Now that number of times can vary every time you run the program, based on the data, based on what the user puts in, based on data that you read in externally. And that's called a for loop, or count controlled. So there's condition controlled, where you have control of the logic as to when that loop satisfies its condition and stops looping. And then you've got count controlled, which again, you control the logic behind how many times you loop through that. I am screen sharing. Yes. Okay. So yeah, while loop. It looks a lot like an if statement. And it kind of is. It's an if statement that keeps going, like the Energizer Bunny. So we call that a while loop, or generically in computer science speak, it's a do while, which in other languages, they would do the syntax. It would be like do on the first line, and then you'd have a chunk of code, statement 1, statement 2, statement 2, statement 3. And then at the bottom, you'd say while while user input is greater than 50,000 or whatever. So the way it's been implemented in different languages is different. That's also called like an until loop, though, because it checks the condition at the end instead of at the beginning, which we're not going to mess with. But that's for you guys that study computer science. Yeah, there are different ways to do it and everything, but we'll be dealing with it's a pre-loop condition check. The while loop is a pre-test loop. Okay, so while and condition here, just like if then else, can be complicated. It can be multi conditional, using the and operator and the or operator, just like any other expression that gets evaluated to be true or false. But while that condition is true, it will do every line of code within that indented block. But those are the two syntactic things to look out for. You got to have that colon after your condition, and then you got to have your white space, your tab, and Notebook will stick that in there for you. Okay, so the next one is a code example. So we are inputting and converting without checking a floating point deposit, which as long as you don't put in something like the letter A, it doesn't, it'll turn a string integer into a floating point without any problem. So we enter a deposit amount, a target amount, and then an interest rate that's a floating point, like a 0.09 for 9%. And then we go into, we set our balance equal to their initial deposit. But you'll see we're messing with balance. So we'll go in and we'll say while balance is less than target. So deposit is our initial, say we want to put in $10. Our target is we want to grow that to $100. This will go through and print the each year it'll compound that interest. Okay, so we set outside the loop, we set our balance equal to our initial deposit, and then we leave deposit alone because that's our initialization value, right? But in our loop condition, we're saying while balance is less than or equal to target. So it's going to check that the first time and do this chunk of code. And then it's going to check that again before it does it a second time, and then check it again before it does it a third time. And if you're not careful as a programmer, it'll do it a 10 millionth time, and you'll have written an endless loop. Do while more electricity. So inside the code, we're setting balance equal to balance times 1 plus the interest rate, which would be like 1.09. So your balance is going to grow slowly each time through the loop. And then we got a counter here called years, and all that's doing is incrementing. Remember, plus equals is our increment operator. So we're setting years equal to years plus 1 in shorthand. And inside the loop, we're printing our years variable and our balance variable. And then this this blank line and the print statement where we print out years by itself, that's outside of the loop because it's not indented. That's critical with Python. Okay, so just like you'd think, we'll run this and we'll enter $10 and we want to grow that to say $50. Our target is 50. So, and we'll do 10% interest. 0.10. If you enter 10, it's gonna be what, like 111%, whatever, 110%. All right. So after year one, 10% growth, you know, you'd think we grew $1, and then it starts to get more floating point. But we see here in year 17, we went over our target. So after we looped through 1, 2, 3, 4, 5, 6, all the way up to 17, at that point, balance became bigger than target. Target was 50. Balance became 50.544. So it doesn't do it again. And we see after outside the loop, we printed our years variable. So that is your basic while loop. It checks the condition every time, and if that condition is true, it executes the code within the loop. Condition-based looping structure. Okay. Doing good. Okay. And then down here, yeah, a note. I mean, I don't know if I wrote an infinite loop this morning, just on the just trying to do this verify user input thingamajiggy. So I had to do Control C, but actually the stop sign did the best for me. It stops what you're doing if you run into an infinite loop. And in Jupyter Notebook, the way to tell that is that asterisk will be sitting there, and you'll be like, what's going on with my code? And if you look next to your code cell where I have the 2 up here, this is N2, that'll be the asterisk. And that means something's going on. Okay. And that's up to you guys. That's up to me. That's up to us to program something inside of the loop that modifies the condition. See, if I hadn't goofed with balance in here, this condition would hardly change. Balance or target, one or the other. The condition wouldn't change. So you just got to keep that in mind as you're solving problems. Okay. Any questions on condition loops?
Sir.
All right. Doing good, Dexter? Okay.
For loops are the hardest ones to me.
Which one?
The for loops.
Yeah, especially in Python. Python's got a particular some Pythonisms that goof with you. And and then again, it kind of depends. If you want to do something 5 times, that's pretty easy. But it's when you start doing conditional looping based on the data, and then you got to think about what the data might contain as you're writing the for loop. And yeah. So, but a for loop in classic computer science is something that you want to do a certain number of times. And there's no real logic test to end the for loop. I want to do this like for every line in a spreadsheet, or for every row in a pandas data frame in our case, or I want to do it for however many times the user told me he wanted to do it, because it could be a simulation. You know, maybe you're writing like a Monte Carlo simulation that simulates the number of times you roll the dice, or whatever the case may be. A for loop does something as many times as you tell it to do it in your program. And the syntax in Python, beg your pardon. The syntax in Python is for, and I guess really this should be a target underscore variable. Target variable is never two words like that. So for a variable in, and you'll notice up here, it looks like a list of values inside square brackets. For target variables, say for, and very often, I don't know why it's been this way forever and they're still doing it. Programmers like to use I as if it's strictly a loop counter and it doesn't mean anything and it's just for a for loop, I, the letter I, lowercase I, is very often used. You still see it in tutorials and in production code. So yeah, it's like I don't know, almost like some of the mathematical reserved letters, omega, sigma. So yeah, for target variable will vary according to this list. The first time, the target variable will be equal to whatever value 1 is in the list. Now, if you've written a for loop in other languages, you're probably thinking, a list? I just normally tell it do something from 1 to 5 or whatever. And you can still do that in Python, but the way it operates is to iterate over the values in a list. We'll get to that in just a second. So yeah, target variable will assume the value in each value in the list. Now, these value 1 and value 2, they can be variables, and it will assume the value of the variable, or they can be literals, either a string literal or a numeric literal. 1, 2, 3, 4, 5, whatever the case may be. But your looping variable, your target variable, will take on that value. So it's not like a for loop in other languages where it will only do from 1 to 10 or 2 to 20 in jumps of 4 or whatever the case may be. It takes on the value of each member of a list. And there's no rules as to what's in that list. It could be a mixture. A Python list can have the numeral 1, the numeric literal 1, and then it can have the next value, and they're separated by commas. The next value in the list could be a string literal Don, and then the next one could be a floating point numeral 4.0. Each one a different data type within the list. So yeah, lists are very, it's like an array in other languages, but we'll get to it. But I got to introduce it so that I can talk about the for loop. So for example, in this very, very, very simple for loop, which says for item in, and then we have a list, a Python list, print the value of that variable. So when we run that, we're going to see 1, 2, howdy, 9, and 4. That just proves that item isn't taking on the value of like 1, 2, 3, 4, and 5, like you might think. It doesn't take on the value of the order of the element of the list. It takes on the actual value. There you go. But if you want to do something that looks more like what we're talking about, there is a function in Python that will return a list that makes the for loop operate the way you think. And it can be a little hoinky to work with, but it works okay. It works fine. So it's a built-in function. You don't need to import any libraries. It's an iterable, meaning it returns a list of values that can be iterated through. That can have as many as 3 arguments, but it doesn't. The second and third are optional. The list of the values in the argument is 0 based, and that's the first thing that well, it's not the first thing that made me shake my head about Python, but first thing about the range function. 0 based means that if I'm wanting to do a loop 6 times, I say for I in range 6, but it doesn't return that range function. Range 6 will not return a list whose members are 1, 2, 3, 4, 5, and 6. It will return 0, 1, 2, 3, 4, and 5. So that's just something to remember. There's a lot of things in Python that are 0 based, where you would be thinking the first something of a, first member of a list, first column in a data frame, whatever the case may be, you would think that would be the 1, but it's not, it's 0. And you'll see that repeatedly. So I'll quit harping on it. The next one is another interesting phenomenon that you have to deal with. For range in 5, 11, that means iterate starting at 5 and ending, but not including 11. So it will loop 5, 6, 7, 8, 9, and 10. So that's how you would these are things that you just have to remember. It's up to, but not including at the end, and it's 0 based at the beginning, which I'm never really confident. I'm always double checking that logic because it just seems so counterintuitive. But native Python programmers, and we got a whole generation of folks that grew up on Python now. It's totally intuitive to them. And then the third thing that you can do is set a step value. So if we want to loop from 2 up to, but not including 11 by 2s, we put this third parameter in there, and that tells you how many values to step each, to increment each time you go through the loop. So 2, 11, and 2 will return a list of 2, 4, 6, 8, 10. So it steps through by 2s, and the step value can be a negative number, even a negative one. And that's how you step from a higher number down to a lower number, which you might need to do depending on the logic. I know I did. And again, sorry for always bringing up the good old days, but when I learned programming in Pascal, there was a down to operator that let the language know you were doing a for loop from high to low, as opposed to this one, which really makes more sense. This one seems more flexible or constant, I guess. Okay. And remember, you can use the target variable, like if it's just a simple loop counter like I, you can use that value inside the loop. And frequently that's absolutely something that you want to do. You don't need an extra counter variable inside the loop. Okay, I think we're back up on break time here, guys. How about 15 after, and we'll go one more session.
Cool.
Any questions on this so far?
No,
Hands-on is everything to me. So I've got some exercises in the next one,
okay, cool.
in the next homework. So yeah, guys, let's come back at 11:15. Okie doke. We'll get started again. Back to looping structures in Python. So yeah, we got the while loop and we got the for loop. Here's an example of our for loop. Now I don't even want to get wrapped around the axle. We're getting a little short of time. This algorithm basically looks at pricing of using soybeans for an example, and iterating through a number of years to set if the price will go up, so we'll plant a little more. Well, that brings the price back down, so we plant a little less, and then it oscillates until it reaches a state of equilibrium. But more importantly, we're just talking about syntax here. We're gathering quantity and the starting year. So that's actually like 2010 or 2012 or whatever. And then 12 times num will be 0 to 11 because of this range 12, the call to the range function. But we don't really do anything with num in this case. It's just a control target variable. So we set price. Here's this algorithm from above. We set the price and then print out the year and set the price, and then we change the quantity based on the price. So like that's what I said. It oscillates higher and lower, high, low, based on I guess bad predictions. Anyway, but we're not testing any of these things, right? We're not ever modifying num, and we don't test quantity up here. We're going to do this 12 times and that's it. So we'll just run that, and you'll see if we start at say we're planting 30, whatever that million bushels or whatever, and we're going to start in 2005. You'll see we start off with 30, sets the price at 17. And then the next year, oh, that's an appealing price. So let's plant 75, whatever it is, million. And that's overproduction. So it oscillates back down to 1250. Oh, let's ramp down production because price went down, which makes the price go back up, which makes the quantity go back up, which makes the price go back down until you reach equilibrium here at planting 60. And it seems to stabilize the algorithm. I'm going to test that real quick here. I'm not in love with this, but like I said, it's tried and true. I've been using it for years and guilty. What did I say, 30? And let's, well, no, it's going to do it 12 times. Yeah, that's, let's start at 60 and 14, see what happens. I screwed up. Let's run it again and say 60 is our start quantity. And 2007. Yeah, that's the magic number. That's the equilibrium based on the math of 20 minus the O1 quantity. So anyway, regardless, it's doing it 12 times. Now, what would make more sense is to do that while price and quantity were not in equilibrium, to give you an idea using simulation as to how many years that would happen. You could probably do it mathematically as well as a for loop, or a loop. Anyway, there's an example of a for loop, a given number of times. And then All this does, it's the exact same stuff, but it uses you tell the program, or you as the programmer are using a user entered variable to decide how many times to run through the loop. So that's the only thing that's really changing here, is that we're doing the number of years. So if I run that and I start at 30 again, and I tell it start in 2009, but I tell it only go 5 years, we never reach equilibrium. But that's just, like I said, this is just code examples, guys, just syntactical examples. So that does the for loop for a given number of years put in by the user. And like I said, that value can come from the user, can come from a file, can come from some other calculation. Okay, and this is a good example of where we want to loop down to. So we're gonna loop from 30 in increments of 6. I'm sorry, 30 down to 6 in increments of -3. So downward from 30 to 6. So it didn't do 6 because it does everything up to, but not including the second one. And the range function is 0 based, but if you put the actual value here, it's going to start at that value. So it's just Pythonisms. There's just idiosyncrasies of this language that you just got to kind of work with it. Now, inside of looping, there are techniques, I would call these things, that lets you kind of keep track of what's going on in the loop. And if you get the logic of them wrong, depending on what you're doing, it can cause you trouble. So we've got accumulators, counters, and sentinels. Now, an accumulator is something that as you're going through the loop, you're doing some math, you want to add the result of that math to like a running total. So it accumulates the results of your calculations. A counter is just that. It counts the number of times through the loop, which can be different, depending on the range function. It's not perfect for a counter, depending on what you're doing, because it's 0 to up to, but including. A counter is actually literally a number of times through the loop that you maintain in your code as a programmer. And we'll see a sentinel value is something that if you want to tell the user, enter a value and then do some processing and then come back and have it do it again, enter another value, or press or enter Q for quit or something like that. Those are called sentinels. When you a sentinel being like a watcher, a guard that guards the loop and tells it when to end. Accumulators, counters, and sentinels. Okay, and of course we have an example down here. So we're going to print out, calculate a total for a number of items entered. So we're going to tell it how many things we want to total up. And then we're going to do a for loop for that number of things, a user defined variable. And we've got a an accumulator right here. So we're going to loop through this for loop. Say I want to tell it I'm going to do this 5 times. So for item in range 5, that's how many items I have that I'm going to total. We go in here and we collect the cost of each individual item. We're going to do that however many times I tell it to, 5. And then we are accumulating the cost of each item. We're adding the cost of each item. We initialize it to 0 outside the loop, but then inside the loop, we say total equals total plus each item. So each time it goes through, you're entering, you are telling it the cost of one of your whatever 5 items. And then we have a counter variable going on in here, which again, you can we could have used max up here because you're going to do the for loop max times, but this is just an example of using a counter variable inside of a loop, because sometimes it isn't this straightforward. In fact, rarely is it this straightforward, and you're going to need a way that in logic, as this thing runs differently every time, you're counting the number of times through the loop. Okay, so we'll do this one. I'm going to enter 5 items. First one is 34, just fat finger and stuff here, guys. So it's going to do this 5 times and then tell me the total for my 5 items is 232. And again, max and count are the same thing. If you're doing a for loop, those are always, there's not really a need for a counter. A while loop is definitely going to need a counter because it's condition based. Okay. And then here's just a note on the shortcut operators, the plus equals and minus equals and star equals. I will use plus equals sometimes, but I didn't grow up learning C, which is kind of one of the places that was using those first, those brief things, and like the increment operator C++, that means to increment the variable C by 1. So I'll write it out longhand, total equals total plus 1. Anyway, but there they are. So there's shorthand operators. If like plus equals, if you're so inclined. Okay, and this next one, we're doing a sentinel value now. We're going to print out, enter -999 when you're done. Instead of saying how many items do you have, because you rarely know a finite value like that. So while they are not entering -999 as a cost, we're going through the same exact algorithm and then printing it out. And that's so item cost is our sentinel. And it, depending on what you're doing, it might make sense, it might not. So we're going to enter all kinds of garbage here. But then when I finally enter 999, it gets to the top of the loop and does this item cost not equal to 999, and it won't do it again. So I entered 1, 2, 3, 4, 5, 6, 7, 8. So like I said, in a while loop is where the utility of a counter is more apparent. But we've got our accumulator in total, and we've got a counter in count, and we've got a sentinel in item cost. And those are just generic terms. There's not really an official, super official definition for those, or a syntactic. It's just how you use them in the code. -99, bam. So yeah, 8 items, 379. So that's how you do all of those. Now this next one is kind of a cool little example. It's nesting a for loop inside of a for loop. So let me see what I wrote. A note I wrote to myself 100 years ago. Python's print function ends with a new line. A programmer with C++ may wonder how to print without a new line. Yeah, end equals, oh yeah, we've talked about that before. So we're saying end equals a space instead of a new line character. We've talked about that before. Okay, so what this does is takes user input for the number of rows that we're going to print. And then inside of a for loop, we're going to have another for loop that is printing on the same line because we've got this end character here. So we're going to have however many number of rows. And you'll notice I'm explicitly saying from 1 to what I typed in +1 because it's up to but not including. So I have to add 1 to the rows to get it to do that, or it would do 1 less than I asked for. Again, I didn't write this language, but it's super popular. Just some things to keep in mind. And then for this one, we use 1 to whatever row we're on. So we're going to print one star or whatever. Yeah, 1 asterisk. And then we're going to go to the next line and then print 2 asterisks. And then the next line and print 3 asterisks, because in this logic, we are using where we are in the outer loop to control what we're doing in the inner loop. And yeah, done this kind of stuff in production. And then within the outer loop, we go to the next line. So this print is happening for each I. So the new line character is printing for each I, which is each line in this triangle. Clear as mud?
Yeah.
So I want to do 10 rows, and it goes through and we get our triangle star pattern. So we get 10 rows, and then so we're doing this outer for loop 10 times from 1 to 10, which includes an inner for loop that we do all 10 times, but we also include a print statement. That's what gets us down to the next line. That's how we got from 1 star on line 1 down to 2 stars on line 2. And you can nest for loops within while loops, within if, elifs, and all of this stuff. You can nest it so that it solves your problem. They're just tools in the toolbox, and it all depends on the flow of the logic as to how you use them. And then this input
I do have a
validation.
question though.
Sure, go ahead, Dexter.
That 1 in the parentheses with the increments, I +1, what is that?
For
The
here.
one below,
For here, right?
the one below it.
Oh, that's the same thing.
Oh, okay.
Okay, so what the +1 is doing is adding 1 to the second parameter of the range function, because the first parameter in the range function tells it to start at 1. The second parameter tells it how many times to do it.
Okay.
So this one, that's how you're getting a star, an extra star for each row that you're on, is because your inner loop here knows that you're on row, say for example 2, the second time you go through this outer loop, and then it knows you're on row 3, then it knows you're on row 4. So that's why it's printing more stars, 1 more on each row that you go on. So that's all that is doing, is adding 1 because it's up to but not including the second parameter. Is that clear?
Yes, sir.
I was it helps to have some coding problems with this one, which is Python problems too. So I won't say make it do or anything, but go ahead and get started on Python problems too, because we pretty much covered everything that you need to do those. But input validation loops, I want to hold off on this. I mean, all it's doing is saying, you know, if goes back to Edgar's question, if they enter, you grab a user value outside the loop, enter a deposit. Since you can't deposit negative money, we do a validation check while deposit is less than 1, and then you restate the exact same input statement. Well, if they put in a negative number, you say that's invalid. Put in a valid entry, and we try and do that into deposit. And as long as they keep putting in negative numbers, it'll keep going through this loop until we got a positive number that we know what to do with, and then we convert it to float. But I wanted to do something, Edgar, that's a little more extensive with try and accept, that doesn't just bounds check a variable, but it also type checks a variable, because Python is so doggone sensitive about data type. So I'm going to keep working on that notebook. We'll see how that goes. So yeah, that's good for today. Pull up Python problems too. Let me make sure I got in the modules. Python programming exercises 2. So this notebook's got some more brain teasers, include loops and whatnot. But well, before we go, I just want to give you just a quick preview. This won't take long. A quick preview of where we're going with with this, as far as working with data, because what we're talking about is really just kind of little console apps and learning the syntax of the language and some logic problem solving. But where we're really going, I need to get to my notebooks. I wrote a program, the little background here. I wrote a little program to go through my data, my training cost data for programs that we fund, looking for invoices that might have not been paid, because there are times, and we don't really have an invoicing program. That's the problem. We don't really have like a QuickBooks where I've got an accounts payable per se. And we don't have an accounting department since we're so small. But what I do is I have basically a customer relationship management application where I enter in the fact that we did get an invoice, and here's the date and here's the amount. And then Bill Yoder, our executive director, he writes checks weekly or so, depending on the amount. He's got to get a cosigner from James Morgan, our chairman of the board of our board of directors, the guy that founded Axiom. Bill has to actually find him physically if there's a check to write for more than like $5,000. So anyway, life at ACDS. So I wrote and it's in my Python directory. Let's do these by name. Here we go. And it is called, well, let me get a data file name real quick. So help me remember. 2000. I did this yesterday. Just ran my status yesterday. 2022-05-23. That's my input file. I'll show you what that looks like real quick. Nasty, right? That's my CSV file. What I've got are 5 columns for each invoice that I possibly could have, because I can't do a repeating table like you would think, like a relational database management system. So I got to have these stupid extra columns. So I've got invoice 1 number, invoice 2 number, invoice 3 number up through 5, dates, amounts, and a status field. And status stays null until Bill writes a check, at which point I plug in, like you see, check number 1093. I enter that. And if I have the date, I'll include that as well. Well, checking for these manually in even in Excel is just kind of boring and error prone. Checking for these that don't have a status. So I wrote this little program 2022-05-23. Where am I? And I called it RTI, which is related technical instruction. Status. Where'd it go? Where am I at? In my data directory. I need to be in my notebooks directory. So I wrote this little program that goes through that. Let me kill all the output. Clear. So we're using this pandas directory I've told you, which is the miracle directory that lets you work with tabular data like a CSV, kind of like you would in Excel. Lets you do all kinds of different stuff to it. And again, this is just a preview here, guys. I just want to kind of show you what we're getting toward. So I'm going to hit. I'll just hit run all. Cell run all. And this data file. I did a report. I wrote a query where I chose the columns and everything out of this system. And so it spits this CSV out in the exact same format every time. So the structure of the data at least is reliable. So that makes it ripe for automation when it's the same data every time. That's what Python is really good at, is automating the boring stuff. So my input data file up there in my data directory is 2022-05-2 yesterday 23. And in my input file here, I append the .csv. So when I actually read it in this next code block, I've put the CSV on there and it won't error. And a lot of this is not error proof. If I put in the wrong file name, I'll get an error that I could trap using a try and an except. That's a bad file name. Try it again, but again, I only get it to the point where it works. I don't make it user proof because I'm the only user. I'm the only one that runs this. So I don't put any time into error checking it. But let me run that. See how it's starring? Everything has got a star next to it. That's similar to an endless loop. It means waiting, processing. And in this case, it's waiting for an input. So in this block of code, I enter the file name. And then down here in this code block, PD is our pandas library, and read CSV is a magical command that goes out to your hard drive and opens up a CSV file and turns it into what's called a data frame. And a data frame is a class of objects. So I've got this data frame object that has many, many, many useful methods associated with it. One, to just look at it and see what you got, is called df.head, which looks at the first 5 rows, the head of the data frame. So you're starting to see here all these different columns. Invoice 1 amount, invoice 3 status. They're not even in order, and they don't have to be. Invoice for number, invoice for date, invoice for amount, invoice for status. So that's a data frame. So it's starting to look like a spreadsheet with column headers. And if you needed them, you could have a unique identifier like this deal ID is a primary key, a unique identifier for each row. I don't use it for anything, but there you go. So next I got just a comment. This DF, and that's my data frame. That's my data frame object. So that is the spreadsheet, DF. .filna will replace all of my null values with 999, like I told you I like to do, in place equals true, something we'll cover in depth when we get to pandas. That means save the changes to the actual data frame. A lot of the stuff that you do is kind of like a function call. It doesn't actually change the variable unless you use this in place operator. I wouldn't have programmed it that way, but I didn't write the pandas library. And then down here, I loop using a for loop for every row in the data frame. I do this if then else logic. Here's another df.shape of 0 gives you the number of rows. So for every row, that's basically what that is saying. For row count in range 0 df, or that's for saying that's basically saying for every row in the data frame. So I'm literally chunking chunk down through the data frame. DF, and then we've got a square bracket invoice number 1. That is a column name. And sub row count is a row. So it's kind of like an Excel column B row 3. It's kind of like iterating like that. So you can tell it, where you're at in the data frame, and you can set stuff, check the value of stuff. So all I'm doing here, and I'd be curious if you would do this a different way with a CSV. All I'm saying is that if there's a value in the invoice number, meaning it's not equal to 999, so I've got a value in invoice number, and I don't have a value in the status, then I increment a counter and I print off this long diagnostic statement saying, hey, we may have an unpaid invoice. And this, whatever it is, 10 lines of code, I was doing it kind of manually. I was going in manually and looking at that CSV with these and kind of looking back and forth to see what blank statuses I had. But then as it got wider and wider, because I had to keep adding a number of invoices, it just became untenable. So this is kind of an idea of the kind of stuff you can automate with just a few lines of Python. So there you go. This is my output, basically, is it tells me which invoices might be unpaid because I don't have the status loaded. And it takes me, literally 30 seconds to get my input file, my data file, and run this little notebook. And I have confidence that I'm telling my boss, hey, I don't know what check number you wrote for an invoice. And it was an interesting programming approach. So what would you guys do? How would you have gone through looking for a value conditionally? There needs to be value in this column if there's a value in that column, without having to do it. Go ahead, Dexter.
I was just thinking I was on my mic. I don't know for sure. I would test it out first. I would loop through the invoice. Is all the invoices like have a value? But you said they don't. Some of them
Not
don't.
necessarily. I can't count on any, there's 5 invoice number fields. And I'm not asking for how to do this in Python differently. I'm saying if you didn't know Python and all you had was Excel or some other spreadsheet program, how would you do this that wasn't something you had to do over and over and over again? And I like I said, I don't know Excel's macro language. I assume you can do this sort of thing in a macro. I just don't know how you would do this quicker, how you would check conditionally that if I've got a number loaded in the invoice, do I not have something in the status times 5 columns of those? So, I mean, think on that. Like I said, I'm not, this was the only way I could think to do it that was fast. And like I said, it runs quickly. This is something that could easily be in a script. That the fact that I've got it interactive in a Jupyter notebook, I could just have a Python program that just runs and spits this out to the screen. I don't, you know what I mean? You don't have to do this kind of thing in a Jupyter notebook, but once you get used to the interactivity, it lets you develop the code and troubleshoot it and prototype it. But then if you were going to put this into production, it would probably be in a script that runs, kind of automatically. And we'll also we got a notebook on files. You can write, you don't have to write this stuff out to a screen. You can actually write a legitimate looking report out to a file that is human readable, just like any other programming language. You can write to a file. You can write to an Excel file. You can write to a Word document. It doesn't have to be a text file. So that was my way of solving this little issue. And like I said, that's what I think the value to a data analyst of knowing a scripting language like this is, because there are so many things that you kind of need to do this with. And if it's the same data every time, you might as well automate it. And I'll show you, there's ways to substitute word search and substitute and chop off, the left hand, however many characters, or upcase it, or there's all kinds of different functions that let you manipulate the data. You can rename the columns. You can get rid of columns that are superfluous, that you don't need. And then you can write the data frame back out to a CSV after you've done all of this wrangling and converting. So I just kind of wanted to give you a preview of where we're going with Python, because it can get a little like, okay, if then else while, whatnot. But this is kind of where we're going with Python. Okay. So for next time, get a jump on problems 2, but I'll give you more time on Thursday to knock out Python problems 2, which is right here in your Python programming module in the classroom. Python exercises 2. If you click on it, you'll see there's a notebook in the exercise that you can download. Python problems 2.ipynb. So download that and take a look at it, and we'll do some more on Thursday. And I'm going to introduce the Excel exploratory data analysis project that I want to do the week following the Excel workshop. So it'll be in 2 weeks. So that's what we'll cover on Thursday. Any questions, concerns? Well, we got everybody here.
No, sir. I don't have any questions.
All right. Thanks, Dexter. Chris, you wanted to stay after, right?
Yes, sir.
Okay. All right, guys. I will pause the recording and see everybody on Thursday morning at 8:30.